Yes, very good morning, dear students. Welcome back to online physics class. So, last class we have discussed about factor on which resistance of a conductor depends, on which factor resistance of a conductor depends, and very important relations about resistance and about resistivity and electrical resistivity of some substance at 20 degrees centigrade. We discussed. So here again, I can recall this electrical resistivity of some substance. We know about very well resistivity means it is also called specific resistance of the conductor. And it is actually proportionality of constant. Why? Because R is directly proportional and R is inversely proportional to 1 by A. So then combining both equation R is directly proportional to L by A. So to remove that proportionality, we will get one proportionality constant, that is a rho. Hence then rho equal to RA by L. Already we discussed that. And the SI unit of resistivity is ohm meter. We know very well. And already I told clearly, resistivity depends on only two factors. That is, one is nature of the material and another one is temperature, right? If you increase the temperature, resistivity of material may be decreases. And resistivity depends nature of the material. Different materials have different resistivities. So just we know already we discussed this conductors, how much resistivity at 20 degrees centigrade from silver to manganese, right? See here, see 1.60 into 10 power of minus 8 for silver. For mercury is 94.0 is 10 power of minus 8. So compared to silver, mercury have more resistivity is there. Why? Because it is a liquid element also. And if you see alloys, it have more resistivity. So you see nichrome have, it is a large resistivity 100 into 10 power of minus 6, constant and have 49 into 10 power of minus 6. And see these insulators have different resistivities are the ranges in between 10 power of 12 to 10 power of 14. So why I'm discussing means here I want to discuss some conclusions about this electrical resistivity of some substance at 20 degrees. The conclusions are seen. So the table 12.2 reveals that the resistivity of an alloy is generally than that of its constituent metals. Already I told alloy itself, it is nothing but combinations of metals or constituent metals. So alloys do not oxidize. Do not oxidize means alloys do not burn readily at higher temperatures. So for that they have more resistivity. If they are not burned, of course, if you increase the temperature. Hence alloys are commonly used in electrical heating devices. Why? Because of course temperatures may be increases. For example, sudden current will become, sometimes voltages will be due to voltage fluctuations also, some electrical heating device does not burn, like electrical iron, toasters, etc. And see, tungsten is used to almost exclusively for filaments of electrical bulbs. So whereas copper and aluminum generally used for electrical transmissions lines, right? Yes. So this is about some conclusion about that electrical resistivity some substance at 20 degrees centigrade. Actually, alloys do not oxidize or do not burn readily at higher temperatures. Further, they have high resistivity. See, for example, in electrical bulb, we are using tungsten. So those tungsten is used almost exclusively for filaments of electrical bulbs. But whereas copper and aluminum, we are not using that in case of electrical bulbs, right? So by because compared to copper and aluminum, some tungsten have some higher electrical resistivity is there. Yes. See, dear students, I discuss some problems related to NCERT. See, the first problem is how much current will an electrical bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm? That is the first question. The second question is how much current will an electrical heater coil draw from a 220 volt source if the resistivity of the heater coil is 100 ohm? See, first problem what they given, what we have to find out. The first problem they given potential difference or voltage they given, and resistance also they given. We have to find out from that current. We know from Ohm's law. See, V equal to 220 volt, R equal to 1200 ohm. So from Ohm's law, V equal to IR. Why? Because V is always directly proportional to current. Potential difference is always directly proportional to current. To remove that proportion, we will get constant R. So from that we want to find out here I. Then I equal to V by R. Then I equal to 220 volt by 1200 volt. Then 0 cancel. Then 22 by 120 is equal to 0.18 ampere. So how much current it will draw? How much current it will draw? 0.18 ampere. See, second problem also, what they given in the second problem, they given voltage again they given resistance. Here also we have to find out current. So just you have to how to solve the problem means, so in the problem what they given, first you have to write, then what we have to find out you can write in somewhere. So from that you can recall formulas, then easily you will do the all problems whatever they given, like from optics also, I mean light chapter also we can do whatever the problems they give. First we have to write what they given, what we have to find out. After that you can think of the formula, what the formula is useful for this, right? Yes. And see second problem also they given 220 r equal to now 100. Again v equal to ir, then I equal to v by r, then I equal to 220 by 100, then I equal to 2.2a. See here thing is the difference of current drawn by an electrical bulb and electrical heater from the same 220 volt source. So the first problem also I am using a source 220 volt only. I mean potential voltage I am using 220 volt only. Second also I am using 220 only, but resistance may be variation. So for that the current will be different. If you resistance will be different, current will be different. So for that only already told, see then V equal to IR, then I equal to V by R. So here I and R are inversely proportional, right? Inversely proportional. Here the voltage remains same, but resistance will be changes and current also will be changed. That all I am telling here. The difference of current drawn by an electrical bulb and electrical heater from the same 220 volt source.